All right, so we're recording. So what can you say about those two sets of data before we've done any analysis of this now? Is there any similarities? What are we trying to find, do you think? So you're given those two bits of data, those two tables of data. What do you think? Sam, what do you think? Did I catch you out again? Pay attention. Yes, ma'am.
It increased in both of them. The data in.
Well, let me stop you. I didn't mean because you're talking rubbish or anything. Before we go into what's actually telling us, maybe my fault. Can you tell me why I would want to look at this data? What's the point? To compare what? In what sense? Length of fish. Why?
To see which is healthier.
If you want to go fishing, you want to know which one's best.
If they want to like eat fish, you want to know which one like bigger, like provide more food.
Yeah, so we're kind of looking at what is there any similarities in the lengths of the fish? All right. Can you already see or make any statements just looking at the two? Neil? Or Sabla, or whatever, yeah. Any Spanish speakers in here? No? Go on. Total number of fishes. No, you were mentioning something about the total number of fish.
Yeah, there were more.
There are more in total in the left-hand one. Okay. All right. So anything else you can tell us? And any little thing you like. Maya.
The frequency increases and then decreases again. So
Okay, so we've got an increase towards the middle and it drops again. Anything else comparing the two?
Oh, well, there's more, like, fish.
That's what Neil said. I want
know,
something different.
but, like-
Something to do with comparing the two.
It's not fair that
No, that's good, fair.
it's not fair.
But we're going to come to what you're saying, so you're right.
You have to do the same.
What about the
amount of
smallest fish? Which river had the smallest fish?
Kalamazoo.
No.
No.
Oh, Sable. There's two of them that were between 10 and 20.
The smallest fish was in the left-hand one. Which one had the largest fish?
They both did.
The correct answer is...
Both.
But there were more of the largest.
We don't know is the correct answer. Why don't we know?
Because it's a group.
Yeah, we don't know if it's somewhere between 130 and 140. Okay. So we're looking at the distribution, the shape, but you've already come up with the problem, haven't you? We're going to compare that the left-hand river has more fish than the right-hand river. Any possible reasons for that? If we were to look that up, Neil?
Could be a better climate.
Could be. It's not even the most basic thing I'm thinking of. I'd say that we could look it up for it. Sam, what would you? Bigger river. Yeah? Could be a bigger river, therefore more fish will be caught. So we're not wanting to necessarily compare exactly the numbers of fish. What we want to know
Wait, actually?
is the shape. We want to compare. So what we want to be able to look at is out of the fish caught, do we have more larger, smaller? That now, if I were to try and draw graphs of those on the same thing, right, same axes, I would. Sienna, leave her alone. It's now on video. Maya stole your stuff.
No.
That's now on YouTube. Right. So we don't want to put two sets of data on the same chart because one will obviously have much higher bars, won't it? And that will lead to a little bit of misunderstanding maybe. So what we want to do is we actually want to do is use what we call relative frequencies. Okay? So we want to compare relative numbers rather than actual numbers. So how could we do that?
Percentage.
Percentages. Okay? So, we don't, why is percentage such a useful tool? Because you've been learning over the years about percentages. I've not done it with you, but you have been doing it. So, what's good about percentages? Neil?
It's out of a set number, which is, or not out of set. It's like,
Why do we want percentage though? I think of it different. Go on.
then the specific amount of it doesn't affect, well, it affects the percentage, but it doesn't
Matter, should we say?
Yeah, it doesn't matter.
Why do you normally want test scores as a percentage? Why do we bother as a percentage? Sam?
Because you can compare multiple ones to the same map.
Standards, yeah. You know, so we have criteria, we have standards. Now, if I give you a bigger test or a shorter test, one's going to have more score, more points available to it, and you'll have longer. So I'm not going to say, oh, to get a 6, you must get at least 48 points. And then I give you a short test where there's only 49 points available, or I give you a long test where there's 300 points available. It's not a fair comparison, is it? Which is kind of like this. So we have a situation here where we're trying to compare two rivers and the fish getting caught, but we want to see what the shape is like rather than the actual numbers. All right. So what we would do in this case is work out percentages. So can we do that? Do you all know how to do that now?
Yes.
No? Okay. So what's important as a percentage? It must be out of compared to the total. So hence we've got a space down here. So I'll just do this first. You tell me what the total is. I'll let you get on and you can do this for yourself in a sec. But what's that total frequency? So 2 divided by 402, so the frequency, okay, divided by the total frequency, then multiplied by 100. What do you get? So 0.5%. And what about the comparative one here? It's 0%. We don't need to worry about that, do we? Okay, so what I'm going to get you to do is for all those data, maybe work it together so you've got all your numbers. I want you to convert both those into your percentage values. And then you're going to do that to start. So this next word is a very important thing to consider when you're doing statistics. Okay? What we've got to be able to identify, so as you get better at maths, as you get more knowledge, and as you look at things in a little bit more detail, what you've got to determine is the difference between the two sets of data significant or not? Has it reached a significant value where it's not ignorable anymore? All right. So you can look at these sets of datas, right? So for instance, let's pick one percentage. I might not ask the ladies down here, but what's the 40 frequency as a percentage? 10%. And the 90 to 100 is 7. What's that percentage? Who told me 8?
Which one was that? Oh, that right.
90 to 100. 6.2. Okay. Now there's a difference there between those two numbers, yeah? Same group, 90 to 100 centimetres is 10% of the fish. This one, 90 to 100 is 6.2% of the fish. Is there a difference between those values?
Yes.
All right. Is that significant? Don't want to answer him because he hasn't told us what's right.
Yes.
I'm asking for your opinion.
I don't think it is.
When is a difference a significant enough difference to consider it? 10%?
Actually, I think that's a little
I'm
bit
doing 7
significant.
plus.
Do you think this one is significant enough?
A little bit significant.
Kinda.
I'm not going to say you're right or wrong. I was,
It's in
not
comparison to the others. So like other variations in percent is more significant.
Well,
than
what's
that.
the difference
That's
between the
kind
two?
of
It's
significant.
pretty much almost 4% difference.
That's kind of a lot.
That's quite a lot, isn't it? Considering this one's only 10%.
Yeah.
All right. So 4% difference. That's 4 in every 100, isn't it?
That's not
That's 1 in every 25. Different. Okay. 4%. Now it is up to you at the moment. What we can do, you see, is when you get to later statistical analyses, you can set yourself what's called a significance level. You can determine yourself what you are going to say is significant enough or not. All right. All I'm going to ask you at the moment to do is, when you're comparing two sets of data, is have an opinion with some reasoning. So do you consider 3.8% when one of them is only 6.2%? Is 3.8% large enough to consider it different or not? All right. So what about the 70 to 80? What is that as a percentage? 7.5%. What about 70 to 80 here?
8.8.
What about that? Is that a significant difference?
No.
1.3% difference, isn't it? So maybe you would say that's not worth worrying about, but maybe you would say that 3.8% is worth worrying about. But again, what I'm saying is, at this stage, I just want you to have an opinion. I want you to be able to say, oh, if I'm comparing these two sets of data, I think that's worth noting, because it's a almost 4% difference in the two. All right? And that's how we can do it with relative frequencies. We can actually compare that. Make sense? Cool. Right, I've just got a bit of practicality news for you before we go. You're not around, are you, after the break? Straight away? Then you'll be back. Okay, good. So I am going to give you a criterion A assessment.
I thought you said you did this was our assessment.
And I also said if some people hadn't done particularly very well, I'd give them a chance to get better.
Did I do particularly well?
I haven't marked everyone's.
I
Did you
don't.
mark
I
mine?
really am getting nervous.
Wait,
Don't. I will let you know straight away. There's no point worrying about it. All you need to know is if at least one person hasn't done as well as I'd hope. We know, if people aren't handing it in on time, maybe, they need a bit of extra help to get their scores back up. But also, now actually, what I've thought about is a number of you have produced reasonable work, but you've not used the things that we've covered in the unit. All right? You've done line graphs and blah, blah, blah. I'm saying everyone, turn that frown upside down.
I think I was very weak in the discussion area.
Yeah, I can't fail all
Don't guys, do not second guess yourself now. All I'm saying is, some of you, the reason is, even if you did well, I haven't marked everyone, even if you did well, I know, but I want people to know that it's coming up. There's no excuse now. Guys, even if you did well, some of you did not use things like stem and leaf, cumulative frequency, group frequency, right? Which, guys, I've just said, if that is fine for your work, that's absolutely fine. But I still want to know if you can use cumulative frequency, stem and leaf, group frequency, estimated means and all that. So I'm going to give you a criterion A assessment in the first week back. All right? After Neil gets back.
Oh, after, so like 3 days after?
Yeah, it won't be immediately. You can have a review.
All those classes be review classes?
No.
Then we're just getting